In this video, we're going to continue with factoring, but this time we're going to be factoring quadratic binomials. So bi means two, so quadratic expressions that have two terms. We're going to start with the expressions that are missing a c, that are in the form ax squared plus bx. When you're doing these, your first step is to look for a greatest common factor. And remember, greatest common factor, that just means the biggest number, or the biggest number slash variable that all terms can be divided by. So if we look at the first example, number 1, let's look at the numbers first. So we have a 5 and a 30. The greatest number that both 5 and 30 can be divided by is 5. So I can factor out a 5. And then if you look at the variables, both of them have an x. So since they both have an x, you can also factor out an x. So I'm going to factor that out. And remember, factoring is the opposite of multiplying. You're figuring out what they multiplied to get your expression. So we want to figure out what goes in this parentheses. We would work backwards or divide. So I'm going to divide both of these by 5x. 5x squared divided by 5x is x, and 30x divided by 5x is 6. So I would get x minus 6. And these would be my two factors. If you were to actually multiply 5x times x, you'd get 5x squared. 5x times negative 6 is negative 30x. So you could check it by multiplying to see if you did it right. In our next example, let's start with the numbers. Here there's an imaginary 1. So if you look at the 6 and 1, the only thing you could divide by is 1. If you look at the variables x squared and x, both of them have an x in them. If there's a 1, you don't have to divide it because it's going to stay the same. So here the only thing I'm going to factor out is the x. And I could divide both of those by x to see what goes inside. So 6x squared divided by x would be 6x. And 1x divided by x would just be a positive 1. So my factors here would be x and 6x plus 1. In the next one, we look at our numbers, 8 and 12. The biggest or greatest common factor that those can be divided by is 4. So I can factor out a 4. And then I have x squared and x, so I can factor out an x from there. So now if I work backwards and divide by 4x, 8x squared divided by 4x is 2x. And 12x divided by 4x would be negative 3. So those would be my factors. Now we're going to look at some examples that are also binomials, but this time they're missing the bx. So it's just going to be ax squared plus c. And similar to this, we're going to start by looking and checking if there's a greatest common factor. If there's not, though, then we can look for something called the difference of squares. Difference of squares works when both terms are perfect squares, but when there's a subtraction or difference in between them. So difference of squares would look something like this. Mx squared minus n. And then when you write your factors, it would look like this. Px plus q and px minus q. So let's go ahead and look at what this means. First, let's do one that has the greatest common factor. Then we'll look at what difference of squares is like. So in number 1, if you're looking for a greatest common factor, 8 and 16 can both be divided by 8. But here, the 16 doesn't have a variable, so I can't factor out an x like in the other problems. So I'm only going to factor out an 8. So I can divide by 8 to see what goes on the inside. So 8x squared divided by 8 is just x squared, and 16 divided by 8 is 2. In question 2, if I look for a greatest common factor, the only number that both of those can be divided by is 1, and both of those don't have variables, so I can't factor out an x. So what I'm going to do here now is I'm going to look at each individual term. So 16x squared is actually a perfect square. What they're doing is they're taking 4x and squaring it. And 25 is also a perfect square, and they're taking 5 and squaring it. When that happens, and there's a minus sign in between, this is called a difference of squares. And you can actually write those as two factors, but one of them is going to have a plus and the other a minus. So the first one would be 4x plus 5. My second would be 4x minus 5. So we're using the same numbers from here, or the same terms. It's just we're putting one with a plus and one with a minus. Our next one's similar. So we have 9x squared and 16. You can't factor out something other than 1 from there, but they are perfect squares. So here 9x squared would be squaring 3x. 16 would be squaring 4. The only problem here is this is not a difference of squares. They're adding. So it's not a difference of squares. So this one's actually not factorable. And if you're wondering why it works when it's a difference, I'll show you right now when you multiply them out. So here, if you were to actually extend this, 4x times 4x would be 16x squared. 4x times negative 5 would be negative 20x. 5 times 4x would be 20x. And 5 times negative 5 would be negative 25. And then those middle terms cancel. And that only happens because it's a difference of squares. So here, these cancel. And you're just left with 16x squared minus 25. Again, that only happens when one's positive and one's negative, which will result in a difference of squares. Let's go ahead and look at our last examples. So here on the next one, if I look for a greatest common factor, the only thing that 4x squared and 81 can be divided by is 1. So I'm going to look for a difference of squares. 4x squared, they're taking 2x and squaring it, and 81 is the square of 9. So since it's a minus here, I can do a difference of squares. Remember, one's plus, one's minus. So I'll have 2x plus 9 and 2x minus 9. Our last example, similar. So here, there's no greatest common factor other than 1. In our first term, they're squaring x. Our second term, they're squaring 10. Because 10 times 10 is 100. And since it's a minus, I know now this is a difference of squares. So I'm going to set mine up. My first one will be x plus 10. My second will be x minus 10. So these are just some strategies to help you factor when they're not trinomials. So when there's only two terms. The main thing is always start by looking for a greatest common factor to see if you can factor that out. If not, look for a difference of squares.